Good morning, all. I am Arshikla Devi, Assistant Professor in Department of Computer Science and Engineering. In this session, we are going to discuss about the subject deep learning. We are going to discuss about the topic bias and variance. So, in bias and variance, before entering into this topic, we must know what is errors in machine learning. So, in machine learning, errors tells us how accurately a model is able to predict unseen data. So, understanding these errors helps us in choosing a better model for a given data set. There are two types of error, that is reducible error and irreducible errors. Reducible error means these can be minimized. They include bias and variance. Irreducible errors means these cannot be reduced because they are caused by unknown or the random factors. So our focus today will be on reducible errors, that is bias and variance. So what is bias? Bias is the difference between the predicted value from a model and the actual value. So it occurs when a model learns the wrong relationship due to the oversimplification. So high bias means the model is too simple and cannot be captured the real pattern. So this is called as underfitting. What low bias means the model understands the data well. And then next, we are going to discuss about the bias examples and reductions. Some algorithms naturally have a higher bias, for example, linear regression, logistic regression, and LDA. These models are simple and may not be capture complex patterns. So, low bias algorithms include decision trees and KNN and SVM. So, if a model has a higher bias, here there are some ways to reduce it. So, first is we have to increase the number of input features and decrease the regularization and use a complex model like adding polynomial features. So these changes helps the model to fit the data better. Next is variance. Variance tells us how much the model predictions changes when the training data changes. So a model with low variance gives a stable prediction even if the data set changes slightly. So a model with high variance gives a very different prediction for a small changes in data. So high variance usually means a model is overfitted, so it learned not just the pattern, it also learned the noise. Next, the examples of variance and its reduction. So algorithms like linear regression and logistic regressions have lower variance. So models like decision tree, SVM, KNN tends to have a high variance. So to reduce the high variance, you can reduce the number of input features, use the simple methods, and increase the training data and increase the regularization. So all these techniques helps the model to avoid overfitting. Next, about the combination of bias and variance, there are four possible combinations: low bias, low variance, low bias, high variance, high bias, low variance, and high bias, high variance. So low bias, low variance means this is the ideal model but very rare. Low bias, high variance means the model is accurate but inconsistent. This is overfitting. High bias, low variance means it is consistent but inaccurate. So this is called as underfitting. And high bias, high variance means it's a worst case scenario and it is inaccurate and inconsistent. And next is identifying bias and variance, how we can detect these problems. High variance, so low training error but high testing error means we can identify we have high variance. And high bias, high training error with a similar higher test error, and understanding this helps us to decide what adjustment the model should need. And next we are going to discuss about the bias and variance trade-off. There is also always a trade-off between the bias and variance. If you make the model simpler, the bias increases and the variance decreases. If you make the model complex, the bias decreases and the variance increases. The goal is to find the sweet spot where the total error is minimal, so the model generalizes well to see in the unseen data. Okay, so this is about, and what are the importance in bias and variance trade-off is, the bias and variance trade-off is central to supervised learning. A good model is one that captures the correct patterns without memorizing a noise. So balancing between bias and variance gives you a best performance. Okay, so thank you for listening. Thank you.